The Fermi paradox asks if there are other advanced alien species, why haven't we detected them? If you delve into this topic you will find a whole lot of utter nonsense written about Kardashev scales, von Neumann probes, and Dyson spheres as if those were even a thing. Here's the deal. Space is a really big place. Really gi-friggin-enormously big. 1 light year is 9.46 times 10 raised to the power of 15 meters. Let's call it 10 trillion km give or take. The first part of the paradox is why haven't we heard from them? We can only observe objects at interstellar distances by measuring their light and radio emissions, i.e. electromagnetic radiation. Radiation spreads out in spherically expanding waves, so the inverse square law predicts that intensity declines with the square of the distance from the source. If we plug in some numbers we can see that in standard MKS units, if our hypothetical alien buddies orbiting Proxima broadcast a signal of 1 watt per meter squared toward us here on Earth, it would decline to only 0.5 times 10 raised to the power of minus 34 watts per meter squared by the time it got here. We can multiply that by any output level we like to get the potential intensity of at that distance. For reference, the intensity of the cosmic microwave background radiation is about 3.7 times 10 raised to the power of 18 watts per meter squared. There are clever tricks that radio astronomers can use with arrays of receivers and by focusing on areas of the radio frequency spectrum that isn't naturally occurring, but even so our alien civilization's total output would be roughly 13 to 16 orders of magnitude below the cosmic microwave background. It's likely none of their signals would be recoverable with our current technology. It is argued that ETS would be blasting a much more powerful signal our way. Perhaps they are, but even if they are shooting megawatts our way, it's still going to be many orders below the cosmic microwave background when it gets here. Why would they want to shout at us like that anyway? Here on Earth, there is no need to shout. Most of our terrestrial communications are broadcast within the atmosphere at signal strengths in the single-digit integer watt range. There are spectacular exceptions like the Taldom transmitter in Russia. Very little of our radio noise leaks to space because it is intended for communication on Earth. It's a safe bet the aliens would also use moderate to low power communications as well, if they even use at all. So even if they are close we probably wouldn't notice. The second part of the paradox is why haven't they visited us yet? Everywhere looks just like everywhere else in space. We have a hard time even detecting the existence of Earth-sized planets in the Goldilocks zone about nearby stars. Our smarter cousins may be better at it than us, but they suffer from the same tyranny of distance. Relativity dictates that nothing physical can travel at, or realistically, even close to, the speed of light. There may not be any aliens zipping along in starships. At the kinds of speeds we can reach now, 0.00023 c, any star is more than 10,000 years away from us. If we could go 100 times faster, say 0.01 c, a trip to the Alpha Centauri group is 400 to 800 years, optimistically, because we have to accelerate and decelerate at the other end. Our ETS have the same physics we do and have to overcome the same limits. They might travel at higher speeds, but unless they are vastly more long-lived than we are, they simply won't survive the trip. But at 0.1 c they might be in the ballpark. Here is another take on this apparent paradox. Let's imagine that the chance of self-destruction for an advanced civilization is 100% before they become capable of roaming the universe. Here are some of the common musings which I think are wrong. 1. The universe is a big place. That doesn't work. Whatever method we apply to compute how many life-friendly planets are out there, we always arrive at ridiculously large numbers. Considering time and statistics, that means many alien civilizations should exist right now that are highly evolved. If we take the human progress trajectory into the next 1,000 years, it's obvious that we will find ways to bridge very large distances quickly, much faster than light. There would be tremendously powerful technology, and the first thing you do with this technology is to search for life. Even we with super primitive tech know how to search for life, but we are lacking the hardware for expeditions. 2. Advanced cultures will turn inside, not outside. Unlikely. Whatever species wins the millions of years of selection will be expansive and aggressive by nature. This is not going away, ever, because that's who we, and they, are, because if we wouldn't exist. The assumptions that advanced civilizations will remove the very core that defines who they are is flawed. People, and aliens, don't do this. In fact, a conscious mind is very likely to be incapable of removing itself. Statistics and tech trajectories simply can't explain why the universe isn't humming with high-tech aliens. Unless we turn our attention to certain inevitable dynamics inside these civilizations. The chance an advanced civilization self-destructs before it reaches universe roaming capability approximates 100%. I call it the self-destruction paradigm. Here is my reasoning and some number games. Let's safely assume that every alien high-tech civilization reaches a point where it can easily self-destruct. Humanity reached that point in the 20th century. And it's getting exponentially worse with every day. Let's define self-destruction as a civilizational regression back to a point where high-tech space travel becomes difficult, a major setback in terms of science, culture, and technology. Like a nuclear war, artificial intelligence nightmare, or disintegration of the planetary ecosystem. Let's also assume that with increasing technology, the number of people needed to initiate self-destruction becomes exponentially smaller. In 1950, you needed one of two major countries to initiate human self-destruction. Today, you need not more than a network of 100, maybe 1,000 bad guys who hack their way towards a few dozen nukes. In the close future, one hacker who creates a self-conscious, evil artificial intelligence in his basement might be enough. Now, let's consider the time between the point at that a civilization reaches self-destruction capability, and the point at that it could freely roam and screen the universe for alien life. It's very hard to exactly estimate this timeline, but it will be quite significant. Let's say 10,000 years, assuming truly exponential technology growth. Now, what are the odds that the civilization will self-destruct within this timeline? Pretty quickly, given exponential scales, a very small number of people, maybe every single member, of the civilization will have the power to destroy the civilization. To make things easier to compute, let's assume it's in average 100 people who have to collude to self-destruct. We can also safely assume perfect connectivity between all members, except for the very first decades. Let's also assume, based on humanity, an average population of 100 billion people. We are already at 7 billion, so 100 billion average over the next 10,000 years is quite low. This means all it takes is 100 people out of 100 billion to collude to self-destruct the civilization, and it only has to happen once during these 10,000 years. Let's assume it takes 1 month for the evil group to plot and executes the self-destruction, also very lenient given that most of the time they will have super artificial intelligence at their disposal. That's right, you have to make sure continuously over 10,000 x 12 months equals 120,000 months that no group of 100 out of 100 billion people decides to go wild, ever. It's also pretty safe to assume that there is no security system in the world to prevent them from doing it, since this level of control is hard to imagine. Maybe there are some safety measures in place to screen for deviance, but at this scale, it's a problem. So basically the civilization must reach a level of wisdom, foresight, and absolutely flawless caring for each other system that out of 100 billion, there will never be 100 people who are pissed or crazy enough to destroy the civilization. It might be possible to build a wisdom infrastructure like this, but it's a Herculean task. And I think that all advanced alien civilizations so far have failed to achieve it. Humanity is utterly unprepared to live up to this task. Fortunately, it will take another 100 or so years before we reach levels of easy universally accessible self-destruction capability. Unfortunately, 100 years is not a lot of time to invent a new wisdom infrastructure that ensures not a single member of the human race has a reason to go crazy. You can think about the self-destruction paradigm both theoretically/mathematically and from a concrete threat assessment perspective. Combine exponential biotech, physics, engineering, AI, and software with terrorism and plot it on a 30-year trajectory from today, and you already get a feeling of the problem. Now do it over the next 100 years, and the problem becomes an existential, high-probability threat. As I alluded to before, self-destruction doesn't always mean total annihilation. But if you get set back 10% of the total every 100 years, you can't go beyond 1,000 years of advancement. And you will never roam the universe freely and scan for aliens everywhere, even though it's so close on your tech trajectory. I don't think the paradox is a paradox at all. It is based on wildly optimistic assumptions about the ease of detection of alien signals. SETI has been processing radio telescope data for decades without a single result. We have reasonable lower bounds for the distance to possible civilizations that are most likely 2 to 10 times as far as Proxima. There's no reason at all to believe alien civilizations are just dying to get here and meet us.